In this video, I want to have a look at a special type of sequence called an arithmetic sequence. So an arithmetic sequence is also sometimes called an AP for short. So AP stands for arithmetic progression, which is just a different name for the same thing. So an arithmetic sequence is a sequence where the difference between successive terms is always constant. So for example, if the first term of our sequence was 2 and the next term in our sequence was 5, then what we've done to get from one to the other is add 3. So it's going to be an arithmetic sequence if that's the same thing happening the whole time. So our next term would be 8, and then 11, and then 14, and it would keep going. So because it's the same difference each time, this would be an arithmetic sequence. It could also be subtracting a number each time, and that would still work as well. So to write that more formally, it's going to be an arithmetic sequence if we take any number in that sequence and we subtract the number or the term directly before it, then we're always going to get the same number. So we're going to call that D for the common difference. So any number we pick in that sequence, any term, if we subtract the one before it, we're always going to get the same difference. A new piece of notation we need is we're always going to call the first term in our sequence A. So if we have an arithmetic sequence, our first term is A. To get to our second term, we'd go A and then we'd add on our common difference. To get to our third term, we'd have A, and we've already got D, but we're going to have to add another one, so we're going to have plus 2D. To get to our fourth term, we'd end up having A plus, so this whole thing plus D again, so A plus 3D, and we could keep going, so T5 would be A plus 4D, and you can start to see the pattern. So what we can do to write this more generally is we can write that Tn, so the nth term of our sequence, is always going to be A, our first term, plus n minus 1D. So that n minus 1, when it was the fifth term, we had a 4 times D. When it was a 4 term, we had a 3 times D. So it's that n minus 1 times our common difference. So let's have a look at a couple of examples of problems involving arithmetic sequences. All right, our first question asks us to test whether the following sequences are arithmetic sequences. So to do that, they have to have a common difference. So for part A, I'm going to take T2 minus T1. So that's going to give me my 11 minus 7, and that will give me 4. So that's the difference between the second and the first term. If I want to check whether it's an arithmetic sequence, that difference has to be the same the whole way along. So if I do T3 minus T2, that would be 15 minus 11, which is also 4. Let's just check one more. So let's try T5 minus T4 this time. So that would be 23 minus 19, which would also give us 4. So therefore, this is an arithmetic sequence, For B, if we do the same thing, let's go T2 minus T1. So that would be 50 minus 46, and that would be 4. T3 minus T2 would be 55 minus 50, which is going to give us a difference of 5. So because they're not the same, that means that that is not an arithmetic sequence. Our second example asks us to write out the first 3 terms and the 15th term of the AP with the first term 28 and difference of minus 3. So we know that because it's an AP, it's going to satisfy the nth term is A plus n minus 1D. So we can fill in our first term and our common difference. So we're going to have that's equal to 28, and I'm going to write it as minus 3 n minus 1 instead. And now we can fill numbers in. I could expand this and simplify it as well if I wanted to, but it's not really going to make much of a difference. Let's go through and do it so you can see it. So we're going to have 28 minus 3n plus 3 if I expand that bracket. So I could write that as 31 minus 3n. So if I want my first 3 terms, I already know that my first term is 28, and we could double check that if we wanted to by filling things in. Our second term is going to be 31 minus 6, so that's going to be 25. My third term, again, you could just minus 3 again, because we know that the difference is minus 3 as we go down the list. So it could be, we could just write 22 from that, but we can put it in here as well. So we'd have 31 minus 9, which would give us 22. It also wants the 15th term, so we don't want to have to minus 3 15 times. What we're going to do is this one, we are going to use that formula. So the 15th term, we'd have 31 minus 3 times 15. So that's 31 minus 45. So that's going to give us minus 14. Our third example asks us to write a formula for the nth term of the sequence, 21, 32, 43, and so on. So to do this, we need to know our first term, which is 21, and we need to know our common difference. So the common difference, again, you can pick any two terms, sequential terms. So let's pick, say, 43 and 32. So we're going to go 43 minus 32, which is going to give us 11. So then we can put it into our formula. We know that Tn is A plus n minus 1d. So we're going to have 21 plus 11 n minus 1. I'm going to expand this out and simplify it. So I'd have 21 plus 11n minus 11, which would give me 11n plus 10. So that's our formula for the nth term. And in our last example, it's asking us how many terms are in the sequence, 4, 9, 14, 19, all the way up to 159. So this one isn't an infinite series or sequence this time because it's got an n term in there. So we're going to start by writing a formula. So we know that our first term is 4, and we need to find our common difference. So that's just going to be 9 minus 4, which is 5. So that means our nth term is going to be 4 plus 5 outside of n minus 1. So that would be 4 plus 5n minus 5, or we could write it as 5n minus 1. So then if we want to find out how many terms, we're going to put this in as Tn. So we're going to write 159 equals 5n minus 1, and then we can solve this for n. So we're going to add 1 to both sides, so we'd have 5n equals 160, and then divide both sides by 5, so 160 over 5, which is going to give us 32. So we've got 32 numbers in that sequence. So that's an introduction to arithmetic sequences.